Okay, moving on to talking about the law of cosines. So the law of cosines, similarly to the law of sines, is used for. Come on now, where are we at? Pen. Is used for oblique triangles, like we talked about before. Okay, these are non-right triangles. When do we use the law of cosines? We use the law of cosines when we know at least two sides. So side angle side and side side side. Now, uh, we've had this situation come up, right? And we talked a little bit about this with the law of sines, the side side angle, okay, or what I refer to as the ambiguous case, right? We can use the law of cosines for an ambiguous case triangle. We're going to look at that in a future video here. Rather than showing you, like we did before, like how we get the law of cosines, we did a video on how to find the law of sines. We're not going to do that. I'm just going to give you the law of cosines for this and explain some of the characteristics of it here. So remember that every lowercase letter here is a side length, okay? And the one capital letter in here, this is an angle. Now, the one thing you want to notice, okay, well, multiple things you really want to notice here, right? One of the sides is isolated in this relationship, okay? Now, what's key here is that whatever side you're going to isolate, the opposite angle is what's involved in the cosine function over here. Okay. The other two sides are squared. They're multiplied here by 2 and times -2 times this. But the biggest thing you want to recognize is that whatever side length you're isolating on this side of the equation, the opposite angle is involved in cosine. And this is the key here, because a lot of times for example, when you're given side angle side like this, you're going to know an angle. The angle that you know is probably going to be the angle that we use in this relationship, right? Okay. Now, play it out a different way. If you know side, side, side for a triangle, you're going to know this, you're going to know this, you're going to know this, which means you're also going to know these values. This is what you're going to be solving for in that situation. You're going to be solving for an angle. And after that, once you have an angle and you have all three of these sides, you're going to have the ability to use the law of sines after that. Okay. And we'll address all this as these types of problems come up. The one thing I will mention is if you look up the law of cosines in a textbook, you're probably going to see 6 different formulas. Okay. 3 of them are going to look very similar to this, right? What they're going to tell you is that there's another formula where b squared is equal to a squared plus c squared minus 2ac times the cosine of b. But this formula isn't different from this formula, right? These variables are arbitrarily named when we draw our triangle. So the way that I've always approached the law of cosines is not to talk about it as 6 different formulas, but rather just one formula and have good algebra skills to be able to manipulate and solve for any one of the values that's in here. Okay, so I'm not going to say that there's a bunch of different formulas. There aren't. All right. The other way that they like to write this sometimes, and I will tell you, when I said that there were 6 different formulas, there'd be 3 of them, one with a squared, one with b squared, one with c squared. And then they also like to write this in terms of cosine. So for example, you might see a formula where it says the cosine of a, and what they do is they take everything here and then they bring it to the other side. So it would be a squared, and you don't need to memorize this, okay? But if we subtracted b squared and c squared over to here, and then we divided by -2bc, okay, we would have this formula, which would give us an isolation of the cosine of a, right? So then that's, again, they'd give you the cosine of b is equal to b squared minus a squared, c squared, so on and so forth. Again, I'm of the opinion that all you need to remember is this one relationship where you have one side being isolated, the opposite angle from that on the other side, and then this other basic format where we're squaring here, multiplying times -2 here, and then being able to manipulate just this. Okay.